Hey, Mr. Myes is here. In this video, we're going to look at the domain of functions and looking at some restrictions and how do we determine the domain of a function. We're really only going to use a couple of types of domain restrictions here, but pretty much most of the... Cell phone's going off. Bad, Mr. Myes. So, what was I saying? Okay, we really only have to worry about a few things about domain restrictions, and then pretty much all the other ones kind of fall in line. So I'm going to go over some rules here and go over some examples, and really it should get you through any type of problem that you have with some exceptions, okay? We probably won't deal with too many of those in my class, but you can pretty much think of all these different things of when we get to composite functions and how these domain restrictions relate to those, okay? So let's take a look at some examples here. First of all, we need to know some rules and some restrictions that we have. First of all polynomials have the domain all real numbers all the time, okay? So any polynomial, x squared, all real numbers. X plus 4, all real numbers. X squared, x cubed plus x to the fourth plus x minus 1, all real numbers. We only have a situation where the domain is restricted when we have a rational function or an irrational function where we have like a square root. Sometimes when we have different things that happen to our function that's not a polynomial, we might have some domain restrictions. So really they boil down most of the time to these two possibilities. First, we cannot have a 0 in the denominator. We all know that. You all know that. We've seen it before. We cannot divide by 0. Number 3 here is that you cannot take the square root or an even root of a negative number. Now, for these, we are dealing with the real plane. So we're dealing with all real numbers. We're not dealing with these complex numbers, imaginary numbers. That is something separate. So for any of these problems, we're talking about the real numbers. So we cannot take the square root or an even root, for that matter, of any negative number. So we're going to have to check for that. Finally, it could be a combination of both 2 and 3. So we could have something where we have a square root in the denominator where we have to have to worry about that. So in that case, we would combine numbers 2 and 3. So let's take a look at some examples. We'll do examples of, well, we won't do one. One, you kind of get the idea. So hopefully you get the idea. I'm making an assumption there, but hopefully you understand that all polynomials have all real numbers. But we will do 2, 3, and 4, and then we'll look at a couple of practice problems, okay? So let's take a look at example number 1. We have f of x equals x plus 1 over x squared minus 9. So we know that the denominator cannot be equal to 0. Hold on one second. I'm a little thirsty here. We know that the denominator cannot be equal to 0, so what we're going to do is we're going to take the denominator and set it equal to 0. Actually, let's set it not equal to 0, because that's basically what we're talking about here. We want the domain of this function f is all values of x where x squared minus 9 will not be 0. Now let's solve it. So x squared cannot be 9, which tells me that x cannot be plus or minus 3. Don't forget your plus or minus 3 when you solve that x, right? All right, so I prefer not to leave my answer like this. I'd like to leave my answer in interval notation because this is an inequality. And in my class, we talked about inequalities from now on being put in interval notation. So let's go and do that. So the interval notation for this, if we thought about a number line, it's negative 3, positive 3. It's all values except for these, so something like that, right? All values except for negative 3 and positive 3. So interval notation, our domain is going to be from negative infinity to negative 3 to positive 3, and positive 3 to infinity. Okay, not very nice putting it in my work here, right? My answer in my work. Maybe I should leave myself some more space. Coincidentally, one of my students asked me the same question. Can you please leave us some more space on our worksheet so that we can do more work? So we can show our work better. I'll have to work on that so I can put some more space. So example number 2. G of x equals 2 times the square root of x minus 4 minus 3. So now we're dealing with situation here number 3, where we cannot have a number that is square rooted. We can't have any negatives in there. So what we're going to do is we're going to take that entire part that's underneath the square root, all of that right here, all that's underneath the square root, and we're going to take that and we're going to set that greater than or equal to 0, right? Because it could be 0, but we want it to be positive, so greater than or equal to 0. So I'm going to take x minus 4. Oops. There goes my air conditioner. And I'm going to set that greater than or equal to 0. And I'm going to solve this. X is greater than or equal to 4. And I'm going to put this in interval notation. So my domain is going to be from 4, all values greater than 4, to infinity. Okay, and that's my domain. Again, if you like, you can draw this on a number line so you can kind of remember how to make that inequality into an interval notation. Okay. So I'll come back and we'll look at some practice problems. Or actually, I'm going to look at one more example and then some practice problems, okay? So we'll be right back. All right, example number 3. So we have h of x equals the square root of x plus 1 over x minus 5. Now this one here has a combination, right? We have a square root on top, on our numerator, and an x minus 5 in our denominator. So we actually have to do both of them and then take the intersection, or we're going to put them together and see what's restricted on both of them, okay? So the first one, we have a square root, so we have to take whatever's inside the square root and put it greater than or equal to 0. Okay, so I'm going to take what's inside the square root, which was x plus 1, and I'm going to make it greater than or equal to 0 and solve that. So I get x is greater than or equal to negative 1. Then I'm going to take the denominator. I'm going to say the denominator cannot be 0. So my x value that it cannot be is 5. Then I have to put those together. So if there's any overlap, I want to make sure that I get the most restricted that I could possibly get. Now, so let's take a look at this. All I'm going to do is put this on a number line so you can see what's going on. So on a number line, we have values that are greater than or equal to 1, something like that. However, when we get to 5 over here, we cannot be equal to 5. So we have an open circle there, right? So now we're going to put this in interval notation. So our domain is going to be values from negative 1 to 5, and then 5 to infinity. Okay, so we're not going to include 5 in our answer. All right? Okay, I will be right back with some practice problems. Okay, here we go. Practice time, right? It's time to practice. We can't do math. We can't learn math unless we practice it, right? So hopefully you take a second here and let me stand out of your way. Go ahead and write these down. Now pause me. And hopefully you worked on them now. Okay, so I'll go over them real quick here with you. We're going to take, and we want to find the domain of each of these. So in this one we have something in our denominator, so we're going to take that denominator and set it not equal to 0. And this is factorable, so we're going to go ahead and factor this to x minus 4, x plus 1. And we're going to get x is not equal to 4, or x is not equal to 1, negative 1. And we're going to write this in interval notation. So in interval notation, we're going to have negative infinity to negative 1. Then we're going to go negative 1 to 4. Then we're going to go 4 to infinity. All right? And they're all open parentheses because it's not included in any of those. Okay? All right, let's take a look at number 2. Here we go. Number 2 has a square root in the denominator as well as an x in the denominator. So we're going to take, you can do this a couple ways, and I'm going to show you the quick way once we've done, once I do this out. So we're going to take x minus 3, and we know that that can't be 0, right? Not equal to 0. So x cannot be 3. But we also know that x minus 3 has to be greater than or equal to 0. So x has to be greater than or equal to 3. Now, hold on. It can't be greater than or equal to 3, right? Because it can't be 3. So if you wanted to, you can kind of do these together at the same time and just get rid of that or equal to sign. So really what we're talking about here is taking x minus 3 and just making it greater than 0. Because it can't be equal to 0. So it can be just greater than 0. So then we're going to have x is greater than 3. Now we're going to write that in notation. So we're going to have 3, oh, I better write my domain. Domain, okay, domain right here. 3 to infinity. And beyond. All right, and there is my domain. Okay, guys, that's it. Domain and range. Catch you later. Bye.